Hello, so this is my demonstration for the term project. I demonstrated my project on April 24th to Cardiac in the science hall during the lecture period. However, I added some extra test cases, I added a few extra test cases, so I will just demonstrate them. Since I already did the normal demonstration, I'll just do the subtraction, show you more of the subtraction. So the first operation I will do is 15.7 minus 6.4, and then here I will input 15.7, which is 4b d9, and then as you can see, the values I'm inputting is in the bottom row. Then I can load it in the top row with a1, so that's 15.7, and then I'll do 6.4. 6.4 is 4666, so 4666, and then I'll load this into my row 2. Then if you press B6, which results in the output, so that's doing 15.7 plus 6.4, so I'm just gonna flip it to minus, and that is 9.3 if you trust me. If you convert it, that'll be 9.3. Then key 0 resets everything, and now I'll do 5.5 minus negative 5.25. So 5.5 is 4580 in hex. 4580. That's 5.5, and then negative 5.25 is C540. So C540 loaded. So 5.5 minus negative 5.25, and if I load it, did it load? Yeah, that is right. It did load. That is actually positive, since I'm doing positive minus a negative number. So that's 10.75. 5.5 minus negative 5.25, 10.75. Is that right? Yep, that is the correct number. And then 1.25 minus 3.75, so 1.25, 3D00, 3D00, and then I'll load it. And then 3.75 is 4380, so 4380. I'll load it, and then I will just output it. So this is 1.25 minus 3.75, which is 2.5, and you can see the leading one is on because it will be a negative number since the b value is greater. And then I'll do my final subtraction demo, which is negative 1.25 minus 3.5. So negative 1.25 is BD00. So BD00. BD00, load it, and then 3.75 is 4380. 4380, is that the right value? Yep. And then if I load it, that is negative 5, because I'm doing negative 1.25 minus 3.75, so negative negative 1.25 minus 3.75 is negative 5, as you can see. And now I'll just do my addition demonstration as well, just in case you forget that I demoed to you. The first one is 3.75 plus 5.125, so 3.75 is 4380, 4380. So that's 4380. Load it into the first one. Let me turn it into addition, and then 5.125 is 4520. 4520. Are these the right values? Let me double check. Yep, they look like they're the right values. Okay, and then if you load it, and that is 8.825, and then the next one was 3.75 minus 5.125, and if you flip it, right here is negative 1.375 if you convert it. Now let me just turn this into addition for the rest of it. So 9.5 plus 0.5625, so 9.5 is 48C0, so 48C0, 9.5, and then 0.5625, 3880, 3880. Load it in to B. Let me make sure these are the right values. 100. Now that I inputted it correctly. Yep, looks like it. And then if you just output it, and that is 10.0625. if you convert it back into normal numbers. And then the next one was 125.125, so 57D2, 57D2, load it in, plus 12.0625, which is 4A08, 4A08. So yep, and this is right. Yes, that is right. Then I'll just load the final answer, which is this right here, which actually is a rounded answer because floating point doesn't have precise enough answer. The real answer would be 137.1875, but I think this is 137.2 if I did my conversions correctly. And this is because, you know, it's rounding because of floating point. And the last case scenario is 1000 plus 1049. 1000 is 63D0, 63D0, and then 1049 is 6419, and then let me load it, and then the final answer is this right here. This is actually 2048, not 2049. Again, it's like floating point precision, so it's not exactly precise to this value, so that it's actually 2048. That's it for my term project. These were my demonstrations. I did the subtraction demonstration from here, and then the addition. I already demonstrated to car decay, but I just wanted to double, you know, just to be safe. Let me get it in focus. Okay.